Hello everyone and welcome to today's tutorial. Our topic today is on lines of best fits. Please kindly watch the previous video on scatter plots because today's topic is a continuation on scatter plots. Okay, without wasting time, what is line of best fit, LBF? This is a trend, that is a straight line. Okay, um, let's look at the plots we have on the right side. We have 5 different data points, and we can make a line pass through this point. In this case, so we have this straight line. In this case, this black line is our line of best fit. In this case, this LBF is passing through the 5 data points, and this is a straight line. A line of best fit may passes through 1, 2, or no points. I'm going to explain this in a later notes. Okay, let's look at this scatter plot. In this case, we have a scatter plot showing different data points, the ones in the cycle blue. And let's look at the first note here. It says lines of best fit is as close as possible to all the data points. So in a case where you have lots of data points on the graph, how do you know where to put the line of best fit? Note, about the same data point above the line as below. That is, let's look at this now. I want to make it red. So I need a light line, and I've selected red. Okay, so if I try to make a line of best fit here, I have something like this. I'm gonna select this. Let's say I have something like this. Okay, all right. So first, let's look at this first illustration. This is a line, but does this give us a line of best fit? How do we know? Below the line, that is this down part, are only 2 data points, but above the line we have lots of data points, so it seems not to be balanced. So this is not a line of best fit. So this point number 2 says about the same data points above the line as below. So if you have about 5 above, you should have about 5 below it. Okay, so we position our line of best fit. If I take it like this, see the new adjustment. Can this be a line of best fit? I don't know. Look at it. Above the line, we have 1, 2, 3, 4, 5, 6, 7, 8. About 8 data points. And below it are 3 data points. It seems not to still be balanced. So you have to readjust it again. So let's see this time around. If I have something like this, boom. Okay. In this case, look at this line. This line is passing through 1, 2, 3, 4, 5. 5 data points. Above it, to its left side, this part is showing only 3 data points, 1, 2, and 3. And below it is also showing 3 data points, 1, 2, 3. So in this case, we can say this red line is a line of best fit. Okay, this red line is a line. This is our line of best fit. As it's fulfilled this point number 2, it says about the same data point above the line as below. we have 3 points above the line and 3 points below the line. And as we can see, is also as close as possible to all the data points, the red line, our line of best fit. So this is how you determine a line of best fit. The third point says this line of best fit helps to make a conjecture, that is a prediction. I'm going to come back to this later. Okay. Before we look at a typical example and see how we can use a line of best fit in a scenario, I'm going to explain a slope concept, as this is very important. Is a tool we are going to be using. Okay, slope. If we have a graph like this, and let's say we have a straight line, let's say we have a straight line like this, okay, and how do we find the slope or the slope intercept? When you have your line of best fit, the first thing you do is to locate any 2 points on this line. For example, let me call this points 1 and another point 2. So the first thing, locate any 2 data points on the line. It could be the one you already have, or just choose any 2 points on the line. So now, how do you find the slope? This point has the y coordinates, something like this, to the y-axis. Remember, this is the y-axis and this is our x-axis. So it's also at the point to the x-axis, okay? And the other points here, we can trace it to the x-axis and to the y-axis. Now, if you look at this, let's say this is 1 and this is 2. This is 1 and this is 2. If you look at this, you can see as it is rising, so we call this place rise. And yeah, from this point on the x-axis, it goes this way, so we call this point run. So what then is slope? In mathematics, how do we get slope out? Simply, slope of this line is the ratio of rise over run. What is this rise? If you look at the rise, is on the y-axis, so from point 1 to point 2. So your rise is change in the y value. So we can put it this way, change in the y value. And that simply means the y value at the point 2 minus the y value at point 1. Okay, this is rise. And the run, as you can see, the run is on the x-axis from point 1 to point 2. So same thing, this is a change in the x value, and that is also the x value at point 2 minus that of 1. So this is how we get our slope. If we represent it, often represented by symbol m. So the slope of this line is y2 minus y1 over x2 minus x1. We're going to see this in a bit in an example. And another thing that is important is what we call the equation of the straight line. The equation of this straight line, or this line of best fit as we have here. So the equation is simply between the two variables y and x, y is equals to the slope, or what we call the gradient, mx plus c, where c is what we call the y-intercept. Okay, and m is the gradient or the slope we've just gotten. We need these two mathematical concepts, slope and this equation, to solve a problem that involves line of best fit and making a prediction. Now I'm going to take you through a practical example. Okay, let's look at this example. We have a graph plot at the left side, which is this. This is our graph plot. Let's say these are scatter plots. And on the right, we have the question that reads, the scatter plot shows the number of coronavirus survivors since January 2020. I beg your pardon, for the sake of this video, this is not a real data, okay? I'm just using this for explanation purpose. The first question says, find the slope of the line of best fit and interpret it. Okay, now how do we find the slope of this line? This is our line of best fit, line of best fit. How do we find the slope of the line? In this case, this line above it, you can see there are two data points above it, 1 and 2, and there are almost 2 data points below it, 1 and 2. So this is a good line of best fit. How do we find the slope? Don't forget, earlier we said identify or locate any 2 points on the line of best fit. So in this case, I want to choose this point. Let's choose this point. That's my point 1. And I want to choose this other point. Let's say, yeah, this is good enough. Let's say this is point number 2. Now, this point number 2 now, if you look at it, it corresponds to this x value 5, and it corresponds to this y value 6. So that means that your parameters for the x comma y, in this case, the point 2 value, that is x2 comma y2, is our x2 is 5 comma the y2 corresponding value is 6. Also, we can get the x1 and y1 of the other point, which is this point here. The corresponding value to the y-axis 1, and the corresponding value to the x-axis is also 1. So we also have 1 comma 1. So with this value, you can find the slope. Okay, so we call the formula for slope, which is what we just did, y2 minus y1 over x2 minus x1, and that gives us our y2, which is 6, minus y1, that is 1, over our x2 value, our x2 value, which is 5, minus our x1 value, which is 1. So this gives us 5 over 4. If you press your calculator, you should get 1.25. So this is the slope represented by letter M. This is the slope of the line of best fit. The question says we should interpret it. So how do you interpret? So what is the meaning of this slope value 1.25? First, go to the y-axis. If you go to the y-axis, it says number of survivors of coronavirus, which is in 1,000. in thousand means that this one you are seeing here actually mean 1 times 1000. So this is 1000, 2000, 3000. Okay, so this y-axis is like saying times 1000. Okay, so if we have 1.25, so what does that mean? It simply means 1.25 times, because on the y-axis the unit is thousand, so we have times 1000, and this is going to give us 1250. So to interpret this, it simply means about, that is, we have about 1250 survived or survivors per month. Survivors per month. Because our x-axis says months since January 2020. So this is the interpretation of the slope. Okay, now let's look at the second example. The second question rather, which says, write an equation for the line of best fit. How do you write an equation for the line of best fit? First, recall this is equation line y equals mx plus c. Okay, so how do we do that here? In this case, so bring out question 2, solving number 2 now. Our equation is y equals mx plus c. The value of y and s can be any of the points you've chosen. Okay, I can use this first point or this second point. You will still get the same answer. So in this case, let's use write an equation. Okay, no, in this case we want to write an equation. Okay, so all we need to put in the value of m, the gradient, and the value of the y-intercept. So my y is going to be equals to m, which is my intercept, 1.25 thousand, remember, so that is 1250, okay, x plus c. My c in this case is the y-intercept. How do you get that out from the graph? From this graph, you see that this line, where does it cut the y-axis? This is my extension of my y-axis and this is my x-axis. So it cuts the y-axis at 0. So that means my y-intercept is 0. Okay, so I can put this as a 0. So, or simply put it as y is equals to, using the main parameter we got, 1.25x plus 0. So this is the equation relating our y-axis and the x-axis. The next says, use the equation to make a conjecture about the possible number of survivors. In May. So this is our graph, May. That's going to be the fifth month. January, February, March, April, May. So the fifth month. So we want to say, based on this plot, how can we predict the possible number of survivors in the month of May? This is May, the fifth month, which is our x-axis. So what that means is that, number 3 now, so our x value we are interested in is 5. So recall the equation you've just gotten, which is y equals 1.25x. So my y is going to be 1.25 times x, which is 5. Then my y equals 6.25. Okay, and what does that mean? Remember that on your y-axis is 1000. So I can have this as my y is 6.25 times 1000. So my y is equals to 6250. And what does this mean? So it means that for the month of May, there is a possibility of having about 6,250 survivors. Thank you. And that's going to be the end. Try and rewind back and listen again to have a better understanding. And don't forget to subscribe to my YouTube channel, Prof. Dan Tutorials. Take care and have a nice day. Bye bye.